Poisson's ratio. That is a remarkable property of all solid materials. Let's talk about that in this video. Let's consider a solid piece of material applied by forces on either side. So as you can see, it is subjected to axial tension, so it will expand and squash sideways, or as you can see here, the length along the line of action of the force increase, whereas the transverse length reduces. So the solid line is the initial shape and the dotted line is the final shape of the material. So it is important to note that one dimension is increasing in this case, whereas the other dimension is decreasing. This dimension is decreasing, and this dimension here is increasing along its axis. So these two things happen at the event of application of a single force or a force along a single axis. Now let's consider if we apply the force on a different axis. It is the same case regardless of which axis you apply the force. There will be one axial strain and a lateral strain. So in this case, the force is applied on a vertical axis, and as you could imagine, that will extend the vertical dimension and squash the horizontal dimension. Again, as in the previous case, the solid line is the initial shape and the dotted line is the final shape. And as you can see here as well, one dimension, which is the vertical one, is extended, whereas the horizontal one is squashed. This dimension is extended and the horizontal one, that is this one, is reduced. So again, with application of a single force, these relation occurs, and that's where we define Poisson's ratio. The Poisson's ratio is the ratio of a lateral strain to an axial strain. It is a dimensionless value and usually fluctuates between 0.25 to 0.35 for most materials. Some cases, value as low as 0.1 can be achieved for some concretes, etc. And for rubber, it can go up to 0.5, but the usual value is between 0.25 to 0.35. So that's a quick summary of Poisson's ratio. As always, if you have any doubts, confusion, please comment and I will come back to you as soon as possible. Thank you.